Hello Year 8, I hope you're all doing very well. I'm just going to set you some questions to get started, and you have 10 retrieval questions here. If you'd like to give yourselves 10 minutes, you can if you wish to. Just press pause, and then when you finish the questions, I'll go through my answers and you can mark your work. Okay. Right, I'm going to go through some answers now, and I'm going to choose a nice pen. I hope you all had a really nice time over Christmas. It's a shame that I'm not going to get to see you in class. Anyway, the first question, I think I would turn both of those fractions into 15ths. I would multiply the first one by 3, and I'd multiply the second one by 5, and I think the answer there must be 13 15ths. Next question, if a is 5, then a squared, add 3 is going to be 5 squared. Add 3, 5 squared is 25, and if I add 3 to that, of course, I get 28. The next one, 4 squared. Well, I know that 4 squared means 4 times 4, and I know that 4 to the 6 means 4 times by 4. I'm going to do that 6 times. So I've got 4 squared, and 1, 2, 3, 4, 5, 6 4's being multiplied. Now, the only way I can really simplify that, especially without a calculator, is 4 to the power of 8. The next question, I think I might choose to turn 3.4 litres into millilitres. Therefore, 3,400 millilitres is definitely smaller than 3,450 millilitres. The next question, I know that 6y must be equal to 30, so y must be equal to 5 because 6 5 is 30. The next question, now I have a choice here. It's either going to be 40 or 50, so I think it must be closer to 40. Number 7, well, if I know that 100% is the amount I start with, which is £45, a nice quick way to find 25% is to quickly cut it in half to get 50%. That's 20 plus £2.50, so that's £22.50, and therefore 25% must be half of that, which is £11.25. So I'm just going to write £11.25 there. Okay, now number 8, this arithmetic sequence, that means that the numbers go up by the same amount each time. I can see there must be 3 jumps worth the same, and I know that 22 subtract 10 is 12. So I know that 3 jumps must be equal to 12. Therefore, I think 1 jump must be equal to 4. So if I add 4 each time, I get the numbers 14 and 18, which must go in between the 10 and 22. Number 9, the word is estimate. That means don't calculate it exactly, but if I was going to estimate number 9, I would choose the numbers 500 and 30 to make that a nice and easy estimate. 5 times 3 is 15. I've got to multiply that by 100 and that by 10. Number 10, as an improper fraction, there are 5 fifths in 1 whole, so there must be 10 fifths in 2 wholes. Add a fifth must be 11 fifths. So the rest of the lesson, we're going to focus on solving equations. And for some of you, you might have done quite a bit of solving equations before Christmas. And for my class, we didn't do that yet. You've got 12 equations in front of you, and I'd like to know how many that you can solve using a calculator if you wish, before I go through them. So give yourself plenty of time, maybe 10 minutes, maybe a bit less. Grab your calculator, write your answers down, and then I'll go through them and you can mark your work. So please press pause. Okay. Now, one of the most important things about equations is that you really need to know what you're doing to both sides to keep the balance. In my first equation, because I'm doing 45 add a to get 101, it means the same thing as a add 45 is 101. It doesn't really matter which way round I've written it. But I think I need to subtract 45 from both sides. And if I subtract 45 from both sides, I'm going to be left with a on the left-hand side, and 101 subtract 45 is 56. So I think that a must be 56. Notice that the positive 45 and the negative 45 cancel out there to make 0. On the next question, I've got f being divided by 6. Well, I want to do the inverse operation to both sides. So if I can multiply both sides by 6, that's the opposite of dividing by 6. So I think f must be 19 multiplied by 6, which is 114. I might just quickly check that 114 divided by 6 gives me 19, and if it does, I can mark it as correct. Number 3, I really want to get k by itself. Adding 91 to it gives 453. So I think if I subtract 91 from both sides, then that will help me find out what k is equal to. That must mean 362 is equal to k. If, like me, you prefer to write the k on the left-hand side, we can just switch the sides there to write the answer. I might check that when I add 91 to 362, I get 453. Now, number 4, I can see that 23 times x is 138. If you're not comfortable with seeing it that way round, you can always write 23 x's are worth 138. I think I might do the inverse operation of multiplying by 23 to find x. So I think I'm going to divide both sides by 23. And if I do that, the multiplying by 23 and the dividing by 23 cancel out, and we get that 1x is worth 6. I might just check that 23 times 6 gives me 138. And it does. I know I've got it right, and I can move on. Number 5, we've got decimals now. Looks a little bit more tricky, but not really, because all we've got to do is got to get h by itself. Notice there's a positive in front of the h, or an add h. It's the same as saying h add 1.8 is 9.2. It just means that the h is a positive value, and that's always quite useful. I think I might subtract 1.8 from both sides there. That means that positive 1.8 and the negative 1.8 cancel out, and I'm left with h is equal to 9.2 subtract 1.8, which is 7.4. I might just double check that 1.8 add 7.4 is 9.2 and mark it as correct before I move on. Trying to get m by itself in the next question, I can see it's been multiplied by 3.3, so I think I might divide both sides by 3.3 in order to find 1m. That means the multiplying by 3.3 and the dividing by 3.3 cancel out on the left-hand side, and I'm left with 1m is worth 6. I might just check before I move on that 3.3 multiplied by 6 is 19.8, which it is, and that's good. Now, number 7, I've got to remember that that fraction line also means divide. So n is being divided by 2.2. Well, I know that multiplying by 2.2 is the opposite, or the inverse operation. And that means that multiplying by 2.2 and dividing by 2.2 cancel out to give n on the right-hand side. And on the left-hand side, that's 13.86. I might just write n is equal to 13.86 because I quite like my variable to be on the left-hand side. Now, before I move on, I'm going to check that I've done it right. So 13.86 divided by 2.2, yes, that gives me 6.3, so I can move on. Question 8, I've got an add y. Well, that means the same as y add 8.3 is equal to 1.9. I can simply subtract 8.3 there from both sides. And if I do that, the add 8.3 is cancelled with the subtract 8.3 to get 0. So I'm left with y is equal to, and that's, this time I've got to be very careful because I'm doing 1.9 subtract 8.3. And writing it like that in that order reminds me that sometimes I'm going to get a negative answer. I might want to check that that's correct. So if I put a negative 6.4 in place of y, 8.3 add negative 6.4, yes it does make 1.9. So I know I've done that correct. We're going to have to be careful with equations because when we get negative answers, we sometimes don't feel very comfortable with that. But what we have to do is we have to realise that if we substitute that into the original equation, does it make sense? Well, that one did. I'm moving on to number 9. Now, I've got to be a bit careful here because I can see lots of subtracts. I can also see lots of negative symbols. Now, in number 9, T has subtract. I've got T subtract 9.2 gives you 1.2. Now, to get T by itself, I'm going to need to cancel out the negative 9.2. There's only one way to do that, and that's to add 9.2 to both sides. Now, if I do that, the negative 9.2 and the positive 9.2 cancel out to give me T on the left-hand side. And if I add 1.2 and 9.2, I'm going to get 10.4. I'm going to check that before I move on. 10.4 subtract 9.2 does give me 1.2. In question 10, I can see that G is being multiplied by negative 3.3. If that were positive 3.3, I could just divide both sides by 3.3. So I've got to be a bit careful here. So instead of dividing by positive 3.3, I'm going to divide by negative 3.3 on both sides. Now, that means the negative 3.3 and that means the multiplying by negative 3.3 and the dividing by negative 3.3 cancel out because they are inverse operations. So I'm left with G is 19.8 divided by negative 3.3. Now, on a calculator, it's possible to use the fraction key or the decimal key. And if you want to press the SD button that looks a little bit like this on your calculator, maybe you could find that if your calculator has one of those. It should, if it's a scientific calculator. You should get G as negative 6. I think I'd check that before I move on. I'll put that back into my original equation. Negative 3.3 multiplied by negative 6. Yes, that does give me 19.8. Now number 11 is looking slightly tricky here. I can see the P is in the numerator of the fraction on the right hand side. Now I'm just going to write it out separately underneath because I've got to be very, very careful with this one. It would cause some students quite a problem. And there's a couple of different ways you could tackle it. For me, I don't like the fact that there's a fraction on the right hand side. And all that fraction means is the P is being divided by 2.2. So I think what I might do to both sides is multiply by 2.2 so that they cancel each other out. So the dividing by 2.2 and the multiplying by 2.2 cancel out. But that's actually going to leave me not just a P, but also a negative on the right hand side. I'm going to get negative 6.3 and multiply it by 2.2. And that gives me negative 13.86. Now that's interesting because negative 13.86 is equal to negative of P. If I multiply both sides by negative 1, I notice that they both become positive. Therefore 13.86 must be the same as 1p. Or if you're like me and like writing the p on the left hand side, p is equal to 13.86. If I were to check that, I would substitute 13.86 into the right hand side and I would do the negative of 13.86 divided by 2.2, and I actually do get the answer negative 6.3 when I type that into my calculator. Number 12, I'm just going to write that down here, says that 1.9 is equal to 8.3 subtract d. I'm going to be really careful here because I've got a negative d. I want to be very careful. I might even wish to write it in a separate order, or a different order I should say. 1.9 is equal to negative d, add 8.3. I don't think that looks very nice to look at. I'm just going to switch the sides round. Negative d add 8.3 is equal to 1.9. I might choose to keep the negative d on the left-hand side and get rid of the positive 8.3 by subtracting 8.3. I'm going to be very careful the order in which I do that. So the positive 8.3 cancels with the negative 8.3. And I'm going to be left with negative d on the left-hand side. On the right-hand side, I've got to be careful. 1.9 subtract 8.3 gives me negative 6.4. So just like in the last question, if I multiply both sides by negative 1, or divide by negative 1, it doesn't really matter, it ends up being the same, I end up getting that d is 6.4. If I were to check to see if that's right, I would want to substitute 6.4 for d in my equation. So, does 8.3 subtract 6.4 make 1.9? It does. I've done it right. Now, I've got some two-step equations for you here. So, they involve exactly what we've just done, but in a couple of steps. So what I'd like you to have a look at is the worked example that I'm going to do. And you've probably come across these equations before, but I'm going to show you the method that I'd really like you to use. Now, because I'm finding x, that's what solving means actually. Let me write that down for you. Solve means to find the value of the variable. Find the value of the variable. And in this case, our variable is the letter that changes value, is x. Now, because I'm finding x, and at the moment x is all tied up with that multiplying by 3, I can't really separate them until I've dealt with the add 10. Now, if I subtract 10 from both sides, I can see that the add 10, subtract 10 cancel out, and I get 3x is worth 22 subtract 10, which is 12. That's great. I want to get the x by itself now. I notice it's being multiplied by 3, so I'm going to divide both sides by 3. And that means the multiplying by 3 and the dividing by 3 cancels out, and I'm left with x is 12 divided by 3, which means that x is 4. I'm going to quickly check. In my equation, let me write the checking stage down. I've got 3x add 10 equals 22. Well, does 3 lots of 4 add 10 make 22? If it does, I've done it right and I can mark my question correct. Don't forget we were finding x and I said that x was 4 and it was. Have a go at the one on the right hand side, press pause, and then I'll go through it. Okay, so I want to isolate the two x's. So first I must subtract 10, just like in the example before. The add 10, the subtract 10 cancel out. Or I could say the positive 10 and the negative 10 cancel out to make 0. And I'm left with two x's are 12. I'm going to divide both sides by 2. And I know that 1x must be equal to 6. I'm going to check it works. And my equation was 2x add 10 makes 22. Does 2 lots of 6 add 10 make 22? Yes, it does. Therefore, my answer was correct. I've now got 10 equations for you to solve. You shouldn't need a calculator to answer any of them. If your answer is not a whole number, you could think about whether it's easier to write it as a fraction or a decimal. I'd like you to show your methods clearly and underline your final answers, and then check your answers that work in the equations. Press pause, give yourself about 10-15 minutes, and then I'm going to go through them. Press pause now, please. Okay, right. So, I'm going to isolate 2x. I'm going to subtract 5 from both sides. I'm left with 2x is equal to 6. Therefore, I'm going to divide both sides by 2. and x is equal to 3. I'm going to check. 2 times 3 is 6 and 5 equals 11. It works. Lovely. Number 2. I will isolate the 2x. So I'm going to subtract 7 from both sides. The add 7, the subtract 7 cancel out. 2 x's are worth 6. I'm going to divide both sides by 2. And I know that the multiplying by 2, the dividing by 2 cancel. And I've got 6 divided by 2. 6 over 2, can write it like that if I wish to, which is 3. I'm going to check to see if it works. 2 times 3 is 6 and 7 is 13. Yes, it works, and therefore my answer was correct. Number 3. Let's highlight my answers to make it easy for you to see. Okay, going to highlight 2 x's first. So my first step, I'm going to subtract 10 from both sides. I'm going to get 2 x's are worth 6. Again, I can see that x is 6 divided by 2. X is 3. I'm going to check to see if it works. 2 times 3 is 6 and 10 does make 16. Lovely, and my answer is correct. Number 4. I'm going to isolate the 3 x's first by subtracting 10. Same step that I've done every time in all of these equations so far. But this time 3 x's are 9. Yay, something different at last. Dividing by 3. I really love solving equations. I find it kind of meditative in a way. And once you get used to it, it is quite meditative. X is 9 over 3, and 9 divided by 3 is 3. Well, I'm going to check. Does 3, lots of 3, add 10 make 19? It certainly does. So therefore, I know that x must be 3, and my answer was right. Let's go to the next page. Number 5. I hope you're doing well here. So I'm going to isolate the 4 x's by subtracting, oh, you guessed it, 10 from each side. Okay, 4 x's are worth 12. Oh, fantastic. I get to divide by something different this time. I think I'm going to divide by 4. Gosh, the variety is great, isn't it? So I'm left with x is 12 over 4. Well, 12 divided by 4 is also known as 3. I'm going to check that 4 lots of 3 and 10 make 22. Yes, they do. So I know that my answer is spot on. Number 6. So 4x. Now I can see, oh, that was my alarm going off. Right, I can see that actually I think this is the same as the last question. I'm going to isolate the positive 4x. I'm just going to check that is a positive 4x. I'm going to subtract 10 from both sides. I'm left with 4 x's are worth 12. Ah yes, x must be worth 3. I mustn't forget to show that I'm dividing both sides by 4. I'm going to check 10 add 4 lots of 3. Yes, I always have to multiply before I add, and I do get 22. So my answer was spot on correct. Have you made any mistakes yet, or have you got them all correct as well? Right, okay, so I've got a positive 4x, that's good news, but this time I've got to get rid of that 100. Oh, the numbers are getting more interesting. So I'm going to subtract 100, add 100, they cancel. I'm left with 4 x's are 120. I'm going to divide both sides by 4 again. They cancel, and I'm going to get x is equal to 30. I'm just going to check that 100 and 4 lots of 30 makes 220, which it does, and therefore x must be 30. Number 8, I've got to isolate 4 x's. I'm going to subtract 100 from both sides. They cancel, and I've got 4 x's equal 10. Uh-oh! I'm going to divide both sides by 4, and let's see what happens. Well, the multiplying and dividing by 4 cancel. X is 10 over 4. Now that's a fraction. I'm going to simplify that fraction to 5 over 2. That fraction is in its simplest form. There's nothing wrong with giving your answer as a fraction, as long as it works. I think 5 over 2 is 2.5, so I could have given it as 2.5. I'm going to check that 4 lots of 2.5 add 100 make 110. Yes, they do, so I know that my answers were correct. So I can give it as 5 over 2 or 2.5. The choice is yours. Personally, I prefer fractions every time. Question 9. 2 x's. I've got to isolate 2 x's. I'm going to subtract 100, and therefore 2 x's must be worth 10. I'm going to divide by 2, and they cancel, and I'm left with x is 10 over 2, which is 5. I'm just going to check that 2 lots of 5 add 100 is 110, which it is. Makes my answer correct, and I can move on to number 10. Now number 10, I've got to isolate 20x, so I'm going to subtract 100 from both sides again. They cancel, and I've got 20x is 10. Now I've got to be careful here because I've got 20 lots of x, so I'm going to have to divide by 20 in order for the multiplying by 20 to cancel. And this is where the order is really important. Notice that I've got 10 divided by 20. Now if I want to simplify that fraction, x is a half. If you insist on writing it as a decimal, it's 0.5. Well, let's just check that 20 lots of a half, which is 10, add 100, does make 110. Yes, it does. If you got that question wrong, and if you put x is equal to 2, that would be the most common mistake. But then you could have picked it up in your checking stage. Because if you thought x was 2, then 20 lots of 2 is 40. Add 100 does not give you 110. So that checking stage is really, really crucial. So I hope that gave you a little bit of a refresher in solving equations. My next lesson will be doing problem solving with solving equations. Anyway, I hope you have a good week back at school, and it's a real shame I'm not going to see you for a long time, but I'll be here making your lessons for you every week, and I hope to catch you up in a live session soon at some point as well. If you need any help, please drop me a line by email or show my homework. Have a good day.